my name is Werner. Welcome to the BaryBot 3D channel. Today on the EDM build, we're going to take some stock 2x2 square tube and turn it into this cart that'll suffice for the EDM machine. This is the goal right here. Before we get started on the build, guys, I wanted to share with you my design and talk a little bit about the water system. In an EDM machine, a wire EDM machine, water is kind of a big deal. And every EDM machine has a pretty elaborate system. I've tried to simplify mine as much as possible. And what it consists of is basically two main tanks. This is the drain tank. So when water's being drained through this apparatus here, it'll come down this stainless steel tube and go into this tank here. From here, an automatic switch will trigger, which will pump the water from that through these 5-micron paper filters, and then through these 1-micron filters here into the freshwater tank. So this is the main freshwater tank. This is the main drain dirty water tank. Now, these filters right here, this is deionized filter cartridges that are in these two. And what'll happen is this is an independent system. So this is a closed loop system into the main tank. When the conductivity of the water gets to be too great, what'll happen is a pump will automatically start filtering water through these DI filters and then back into the tank in a closed loop. And so what it'll do is I have a controller that's going to be mounted right here on this control panel that'll constantly monitor the conductivity of the water, and it'll automatically adjust and make corrections as needed. So this is micro Siemens that we're looking for. Between 15 and 20 micro Siemens is what I'm looking for as far as conductivity. The two pumps that you see here, this is the main fill pump. And I haven't modeled it in because I moved a few things, but it's going to have a big, huge 2-inch tube that goes from here, feeds up through this into this this funnel looking thing right here. And basically what it'll do is it'll put a blade of water. Now this thing throws a lot of water through it. And for that reason, I've got it going into a blade and to a deflector down here, so it'll shoot the water into this tank. This whole tank will fill up within probably about 45 seconds. So it's about 15 gallons, and it'll dump it in there within probably between 30 and 45 seconds. So quite a large stream of water will come from this pump. This is actually a pump that's used for jacuzzi spa tubs, to give you an idea of how much water flow is going to be coming through this. And you can see the pickup is from the bottom of the freshwater tank right here. Now, this is a high pressure pump here. It's not huge volume. It's only 2.5 gallons per minute, but it's 250 PSI, up to 250 PSI. I won't need that much for my flush cups, and that's what this is going to be servicing. The flush cups are located right here and here. And so what it does is it puts a stream of water right where the wire is cutting the material. And this can work with, I'll be able to adjust. This will be the pressure coming from the pump. This will be to regulate the pressure from the top and the bottom flush cup. So what I'll do is I'll have some gauges here so I can get this dialed in. And there's a lot of factors, a lot of reasons why you may want more or less water flow. And as we do more of this, I'll talk more about why you might want one over the other. And yeah, the water system's pretty elaborate. Quite a lot going on with water. One of the cool things, and I'll show you this during my build, is this piece of tube right here. This member actually has a key that I can just pop it right out. And that allows me to get this flush tank in and out very easily. It works really cool. It wasn't needed for any structural reason. It's got this piece of 2.5 by 2.5 3/16 angles welded to these two tubes, and then it's welded here with a pretty heavy gauge. By the way, all this 2x2 tubing that you see for the main frame is all 14 gauge 2x2 steel tubing, and then this bottom panel here is a 16 gauge. And I do have a couple of extra supports here. You'll see they're not modeled, but you'll see it in the real thing. So yeah, you know, these tanks will be easily removable, so I can take them out and I can pressure wash them. This is a pretty big opening. I can get my pressure nozzle in there, and I may end up cutting this whole thing out, putting an aluminum bezel on it and another lid for easy cleaning, but we'll just see how this goes. This should always have really clean water, and if I'm a good steward of my filters, it should be pretty easy to keep this water clean and keep this tank from getting all yucky. I'll probably also add an ultraviolet filter for the water to help kill off bacteria, but that's something I may do down the road. This tank is really easy to pop out, and it's got a pretty nice big opening on the top of it. So this one will be really easy to clean, and this will be the one that gets more dirty because it'll have a lot of sediment coming into it from the from the machining process. One thing I wanted to point out is this right here is going to be a control panel. It'll have some controls that deal with the wire feed and possibly even being able to jog the machine around, jog the C-arc around. So this will have some adjustability on this pivot, so I could spin it out of the way or pull it in, depending on when I need it. On the back here, this shelf, this was a mechanism I designed to have a take-up reel, so that it was driven off of this feed reel. It would automatically have take up, and it had a slip system. So it actually didn't need any motors to work. But I'm going to go ahead and I'm not going to do this. I'm just going to go straight into making a wire chopper similar to what Mike did. And I think that's going to work really well. So, of course, this is the BX17 up here. And my control panel over here on the side, which is super cool. This is a really nice control box that I got I actually bought it for another project, but I'm going to use it on this one because I didn't need it on the other one. So, yeah, it's looking really good. I'm really excited about it. So let's go ahead and we'll get into the build. I chopped it up on my chop saw instead of using the horizontal bandsaw, which worked really well. And then you guys know the routine. I went through and thoroughly degreased, deburred and wiped everything down. And then followed up with the orbital sander to give myself a really good surface to paint. It looks like a lot of work, but it really isn't. It went pretty quick. In the process of welding up my frame, I used a couple of my welders, the MP210 MIG welder, along with the TIG welder. If you have tight joints like you see here, the TIG is great for fusing these butt joints. If you get the settings just right on your welders, it makes blending the welds like this really a piece of cake. I really enjoy using these flap discs. This is one area where you don't want to stench trying to save money. Buy the best quality flap discs you can get. I really like the Norton, Walters, and 3M brands. Next up, I'm cutting some blanks out of some 1/4 by 4 inch flat bar. This is cold rolled material, and I'm using these for plates to mount the casters on the bottom of the cart. I'll chop 4 of them up here, and we'll deburr them and take them over to the milling machine to drill the holes and tap them. This is the next thing I'm working on here, is a frame to help hold up the drain tank. I made this frame so that it would be easy to take the tank in and out of the cart. Here I've got a small piece of 1/2 by 1/2 inch tubing. I'm just using it as a temporary holder. Just throwing a couple small tacks on it and it'll hold it in place until I can get it all situated, and then I can tip that last piece of angle upside down. That'll create the shelf for the tank. You see me using these laboratory scissor jacks. They come in super handy. I've got 4 of them that are a little smaller and then that one big one. And I find myself using them all the time to get things really dialed in. This is a super old digital level. I've had this ever since I was a young kid. Works super good. Kind of getting things organized, making sure everything fits according to plan. And it's really starting to come together. I really love my new scissor lift. I find I'm using this thing more and more all the time. I received this card along with the DI tanks from Spotless, and they're usually used for automotive detailing. They're fairly large and they should last me a long time before I have to clean them out, or change them out rather. And I'm just hacking this piece of bracket off here that I can use since it was already all machined to hold those cartridges. Makes it easy. Here I'm just welding in the rest of the tube I need for the structure to hold my BX17 and my wire chopper. This is also going to help support the control cabinet that you'll see in a little bit. I am machining up these couple little blocks here They'll be used to fasten the control cabinet to the frame. Just made them out of some 1/2x1 bar stock, drilling and tapping them. Always remembering to move the parallel out of the way. This is a case where it's so nice to have my tapping arm right on my mill. All I do is move the table over and it's ready to go. Here's another one of my favorite tools. This is made by Noga tool and it came in some sets. I bought some deburring sets and this little gadget was in it and I really enjoy using that. Something so satisfying about deburring like that. Here I'm drilling the holes that will be, the fasteners will go through these holes here into those blocks once I get them welded in place. The way I did this is by mounting those blocks right onto the cabinet, and then I positioned the cabinet using some shims onto the frame so they'd be perfect for welding. Then I went ahead and just tacked them in place, pulled the cabinet back off, and finished welding them. Here's a control cabinet I purchased for another machine I was building, but thought it would be much better suited for the EDM machine. It's a super nice cabinet. You can see the cam latch here. Really, really well made. I bought it so long ago, I can't remember what I paid for it, but I think it was somewhere around $160. Here's a piece that I'm going to show you next, how I made it. This is a section, the tube that comes out to allow me to get the tank that the drain water goes into in and out of the cart easily. This is a little trick that I use. I cut off a section, I think it was about 5 inches of that 2x2 square tube. And what I'm doing is just machining the corners off. That allows me to reassemble it, and it'll be an insert. It'll slide within the 2x2 tube, being that it's smaller now. Just cleaning it up here so I can get it welded together. Deburring it with my favorite little belt sander. You can see I cut a couple small sections of the 2x2 tube so I could tack it in place. Here I'm just TIG welding the corners. A quick cleanup on the 2x72 belt sander, and this little slug fits in really nicely. Here I'm going to use my little mini belt sander to grind off the little bead that's inside of this tube that has a seam. Basically, it leaves a small bead of weld on the inside of it, and so using some 80 grit sandpaper on my mini belt sander just grinds it right off. That'll allow my little plug to slip in there really nicely. Here I have a small piece of like 1/4x1 bar stock, maybe about 2.5 inches long, that I'm slipping into the tube. I drilled a couple holes in that 2x2 tube that I can put a couple of plug welds in there to hold the piece in place. Then I'll drill it and tap it. This will just be the handle, so I can retract this little plug to allow me to get the piece out. This is a really great trick if you want to have some good threads in a piece of thin wall tubing. in this operation here, I have some 2x2 6061 aluminum bar stock that I'm machining down. What I'm doing is I'm making some slugs that I can fit into the 2x2 tube, and just cutting it, milling it down to size. We'll take it over to the bandsaw and chop it up into little pieces that are 1/2 inch thick. Okay guys, I've got a little operation going on here. I've scuffed up with some with a little belt sander in here, and I scuffed up a little section right here in this tube. And what we're going to do is we're going to glue in some of these slugs. So I think I've got everything set up. I'm just going to go ahead and see if I can mix up some epoxy. We're going to put it into this syringe, and that way I can inject it in here. Then we'll go ahead and push the slug in and get it positioned exactly there. What I'm going to do is go ahead and locate on this tube here. This is going to be my ram. I'm just going to put a line here so I know how far in I want to go with it. Basically what I'm doing is this is the plug that goes in. And so I've got the distance of this plus this spring when it's compressed back here. So that'll push this thing out. And this is the one that's going to go in here, and then I've got another one for the back. This little one's going in the back. So let's see if we can mix up some epoxy without making too big of a mess here. The epoxy that I'm using is one of my favorites. This is called T88. And it's a structural epoxy used a lot in aircraft manufacturing, like composite aircraft building and whatnot. This stuff is amazing. And this is System 3 is the manufacturer. By the way, if epoxy ever crystallizes on you in large containers like this, what you can do is go ahead and throw it in the microwave just for about 10-15 seconds, and it's amazing. It just makes it nice and liquid again, and makes it usable. If you've never used epoxies before, be really cautious the first couple times that you do it, because do small quantities. Some people have a deathly allergic reaction to epoxies. And one of my buddies, Bert Rattan, an expert at Scaled Composites, engineer with epoxies and composites, I once listened to a lecture he put on. He said everybody's born with a container on their hip. And basically every time you work with epoxy, you put a little bit in that container. Unfortunately for some people, the container's the size of a thimble. They've got zero tolerance. Others have a 55-gallon drum. And I must have been fortunate and had a 55-gallon drum, but eventually that thing will be full, and then I'm going to be in trouble and have a terrible allergic reaction too. It can be anything from skin irritation, terrible skin rashes, or it can be respiratory to severe headaches. It runs the gamut of what can be wrong. But anyway, just be cautious. Always do it in really well ventilated areas. And again, use caution the first few times that you do it. One of the things I like about this T88 system is that it's a really slow cure epoxy. Not only is it amazingly strong, but it's slow curing, so it really takes overnight to fully set up, and which is really nice in a lot of cases. Should have grabbed a few little gloves here. I'm going to run and get them. Alrighty. What I did is I went ahead and put this, because I want to eject it right in the inside of this tube, right at that distance right there. So what I did is I made a mark on it, and that's going to allow me to keep tabs on where I've got it positioned. Just throwing a little bit of this stuff on here to keep that tube located where I want it. All right. Oh, yummy. There we go, that should be plenty. Now what I'm going to do is blow in this to create a little bit of air so that we can get some of the air out of this thing. There we go. I'll start off with the back of this. I'm just going to put a little bead right in here. Okay, I got a little bit on the back. Now we'll do this section here, and this is where I want to go in to about there. So I'll just go ahead and start feeding it. Rotate, do a little more. All right. Oh yeah, I got a nice nice bead all the way in there, and got a little bit on the back here too, so we should be good. All right. So this one will drive this one home. That's the one that goes back here. This one just barely needs to stick out. That's good enough. So that's about how much I want that one out. And the one with the spring, this guy, it goes better one way than another. So let me see if I can figure out which way it goes. There we go. So what I'm going to do is just keep pounding it until I get it up to this line here. I love this fixture table. All right, guys, that should be it. Oh yeah, it looks wonderful. See down in there? And this one's sitting perfectly. And so we'll go ahead and leave that to cure tonight, and I'm done for the day. So we'll get back at it tomorrow morning. Here's that insert piece we just fabricated, and it worked out slick. I'm really happy with it. You'll notice that I have some rails on the bottom of it that are there to accept a side panel. I'm going to go ahead and enclose this thing on 3 sides, leaving the back open for ventilation. Here's the handle to draw that little slug back to pull the part out. Here's a better view of those rails for the side panels. You're going to see more of this in the next video. I'm kind of doing it a little differently from normal. I'm going to use some 1/4 inch MDF and just finish off the edges so that they're watertight. You guys have seen me do this many times. I'm just cleaning everything up, and I'm going to give them a nice sanding here. Get them ready for paint. Then we'll tack them on. I 3D printed these little parts here that I'm using on my mini mags. And it's just making a really nice little fixture to hold these rails in place so I can get them tacked perfectly in alignment. Worked out super nice. Here I've got a piece of MDF that I sliced to 5/16 of an inch. This leaves me enough room for some play and just getting them tacked into place. It made pretty quick work of it. I left the rails a little short on the sides, just so that if the water ever got in there, it could easily drain. Here I got fabricated the bottom panel for the cart and just giving it a good deburr sanding. Again, my scissor lift is so awesome. Staging everything in the paint booth, I went ahead and tipped it upside down so I could put a really good coat of paint on the underside. One thing I like to do is use that stretch wrap to cover up things I don't want to paint. This just helps save time since I don't have to remove those casters. Turned out super nice. Whole bunch of stuff to see in the next video. I really appreciate you guys watching. Please stay tuned.